So we're going to talk about cofunction identities and sum and difference formulas at the top of page 8 in your Unit 14 packet. So two functions are cofunctions of each other if there's a relationship between the given angle and its complement, as well as the trig function and its cofunction. So there is a relationship. I don't want to tell you just yet. We'll kind of discover it together. So assuming that the triangle that you see, there's a right triangle at the bottom, we're going to define the bottom angle, the bottom acute angle as theta, and then the top angle, we can find what that measure is as long as we know that whatever the value of theta is equal to, we take the difference between 90 and theta and get the top angle to be 90 degrees minus theta, or in other words, pi over 2 minus theta. Pi over 2 is 90 degrees in radians. So if I asked us to take a look at pi over 2 minus theta as just the name of the angle. So if we're standing at the top, if this is where we're at, and we're asked to find sine of that angle using right triangle trig, sine is opposite over hypotenuse, so B over C. And then I asked you to change your perspective and then find cosine of angle theta. So we'd be standing here, find cosine. Cosine right triangle trig is adjacent over hypotenuse. And what we observe is that sine and cosine are what we define as cofunctions of each other. And if we're taking sine and cosine cofunctions of each other of complementary angles, what we observe is that they are congruent to each other. So with both of those being congruent to B over C, we can conclude that they're congruent to each other, so that these two are equal to each other. So these two right here are equal using substitution. So I can say that on top, let's fill in our identity. Sine of pi over 2 minus theta is equal to its cofunction of just theta. And then the opposite is also true. Cosine of pi over 2 minus theta is equal to sine of theta. We can go through and observe similar relationships in tangent and cotangent, as well as cosecant and secant. So these all are what we call cofunctions of each other. Tangent, cotangent, cosecant and secant are cofunctions of each other. And so if they are, then tangent of pi over 2 minus theta we can conclude is equal to cotangent of theta, and cotangent of pi over 2 minus theta is equal to tangent of its complement, tangent of theta. And same on the right hand side. Cosecant of pi over 2 minus theta is equal to secant of theta. Secant of pi over 2 minus theta is equal to cosecant of theta. And so those are the properties and identities of cofunctions. So you do have to know that sine and cosine are a pair of cofunctions, and then tangent, cotangent are a pair of cofunctions, and cosecant, secant are a pair of cofunctions. The sum and difference formulas are given below. So these are used to find angle measures that might not fall on the unit circle, but they allow us to find exact values of angles that are the result of a sum or difference of the angle measures on the unit circle. So you can see below there, 345 degrees is not on the unit circle. However, it is the result of two angle measures that are either added or subtracted to get 345 degrees that you can find on the unit circle. So it might come across to you as familiar because 45 degrees. If you break apart 345, it's the same thing as 300 plus 45, which are both of those angle measures are part of the unit circle. So when we're looking at the formulas, I'm just going to say you don't have to memorize it. You have it in front of you. In pre-calc honors, you might be expected to memorize it. So I will just make a comment about what it means to be commutative. So if I, for example, on that 345 degrees, 300 plus 45 is the same thing as 45 plus 300. So what you define as U and V doesn't matter. So as you're plugging it in, you just want to make sure that you stay consistent with the order that you have on the left when it comes to things where the values of u and v are not commutative, such as when you're taking a look at the difference between u minus v. So whatever you define first as u must be in the same spot as the u's on your on the right side of your equation. However, if it is the sum and you happen to switch 345 as 45 plus 300, you just want to make sure you stay consistent on the right hand side, but it doesn't matter which one is u and which one's v. However, if it's a difference, it does matter. So that's true for the set of tangent sum and difference formulas as well as cosine. So we'll take a look at the next example on the